Good morning one and all. My name is Dr.B.V. Rajanna, Associate Professor, Department of EEE, MLR Institute of Technology, Hyderabad. Today I am going to give lecture on the subject power electronics on the topic inverters. So this is my overview of presentation. So first I will discuss about the inverters and what is an inverter, history of inverter, applications of inverter, what kind of inverter do I want, the next use of inverters, classification of inverter, single phase full wave inverter, static inverter, dynamic inverter, characteristics of good inverter, conclusion, summary. So this is the overview of my presentation. So what is an inverter? So an inverter is an electrical circuit. An inverter is an electrical circuit capable of turning DC power to AC power, while at the same time regulating the voltage, current and frequency of the signal. So this is we can say inverter converts fixed DC voltage input to variable AC voltage output, or it can be power also. So this is the inverter use, and this is the how the inverter look like. So how the inverter look like. So introduction. So an inverter is a device that changes or inverts direct current DC input to alternating current output. So it does not create or make electricity, just changes it from one form to another. So DC is changed to AC out. So output is usually 120 or 240 volts or 60 cycle alternating current to match line power. Inverters are often a good choice for applications that require the main engine to operate at a job site, that is powering hydraulic systems or air compressors. Since inverters are electronic devices, we don't have the noise. These are the electronic devices, so we don't have the noise from a separate engine. An inverter requires no fuel and virtually no maintenance. Since inverter output is fully voltage and frequency regulated, it's a fully voltage and frequency regulated and functions independently from the speed of the engine. So history of inverter now we will discuss. From the late 19th century through the middle of the 20th century, DC to AC power conversion was accomplished using rotary inverters or motor generator sets. So that is called MG sets, we call motor generator sets. In the early 20th century, vacuum tubes and gas filled tubes began to be used. So vacuum tubes began to be used and gas filled tubes began to be used as switches in inverter circuits. So in the late 19th century through the middle, DC to AC power conversion was accomplished using rotary converters or motor generator sets, these MG sets. In the early 20th century, vacuum tubes and gas filled tubes began to be used as switches in inverter circuits. And application, that is the use of inverter in DC power source utilization, and next uninterruptible power supplies, induction heating, HVDC power transmission, variable frequency drives, electric vehicle drives, the general case. So these are the applications of inverter. So what kind of inverter do I want? So inverters come in all different shapes and sizes for all different purposes. So inverters vary in output from 50 to 5000 watts. Several different methods of changing DC power to AC power. Some inverters put out electricity of higher quality than others. What does that mean? So we will study in detail. DC power source utilization. So DC power source utilization applications include use of DC in motor, vehicles and from batteries to power, AC loads and use of energy from solar cells to power AC loads. An inverter converts the DC electricity from sources such as batteries, solar panels or fuel cells to AC electricity. The electricity can be at any required voltage, particularly it can operate AC equipment designed for main operation or rectified to DC at any desired voltage. Uses of inverter. So DC power source utilization applications include use of DC in motor vehicles and from batteries to power AC loads and use of energy from solar cells to power AC loads. Uninterruptible power supplies. An uninterruptible power supply uses batteries. An uninterruptible power supply uses batteries and an inverter to supply AC power when power is not available. When main power is restored, a rectifier used to supply DC power to recharge the batteries. Induction heating. Inverters convert low frequency main AC power to a higher frequency for use in induction heating. To do this, AC power is first rectified to provide DC power. The inverter then changes DC power to high frequency AC power. Classification of inverter. So based on charging process, a power inverter converts DC power or direct current to standard AC power or alternating current. Next, solar inverter. A solar inverter is a type of electrical inverter that is made to change the direct current electricity from a photovoltaic array into alternating current. Next, wind power inverter based on utility. So based on utility, independent control inverter, grid connected inverter. Single phase inverter. It is of two types: current source inverter, voltage source inverter. And single phase half bridge inverter, it consists of voltage source, two diodes, two thyristors. So here we can call these are the two voltage sources. So here Vs by 2, Vs by 2, two voltage sources. And this is the output voltage. And this is the source current, and these are the diode D1, and this is diode D2, this is diode D2, and this is the thyristor T1, thyristor T2, and this is the output current or the load current. So here this is the circuit of a single phase inverter. So operation of half bridge inverter we will discuss. So for 0 less than t less than or equal to t by 2, then thyristor T1 conducts, load voltage is equal to Vs by 2 due to upper source voltage Vs by 2, and t equal to t by 2, thyristor T1 is turned off by commutation and T2 is turned on, and from t by 2 less than t less than equal to t, thyristor T2 conducts and load voltage is equal to minus Vs by 2. Due to lower voltage Vs by 2, amplitude of load voltage is equal to Vs by 2. So here we can see this is the gate current pulses, gate current. So this is the step pulses we are giving, and this is the gate current at channel 2, thyristor 2. So gate current of T1, this is the gate current of T2 thyristor, and here T1, then next here again T1 current and here T2. So this is the waveform here. So this is the Vs by 2 voltage and this is minus Vs by 2 voltage. So this is the time period here. So time period, total time period. So this is the waveform of a single phase half bridge inverter. Single phase full bridge inverter, here it consists of 4 thyristors, 4 diodes. Amplitude of output voltage is doubled, whereas output power is 4 times to that of the single phase half bridge inverter. So here there are the 1, 2, 3, 4. So total 4 thyristors. It involves 4 thyristors and 4 diodes, D1, D2, D3, D4. So 4 diodes it is having. Here this is the source voltage, Vs. So this is, and this is the source current. So this is the circuit of single phase full bridge inverter, and this is the output current, and this is the output voltage. Operation of full bridge inverter. For full bridge inverter, when T1, T2 conduct, load voltage is Vs. When T3, T4 conduct, load voltage is minus Vs. T1, T2 do not conduct simultaneously. If this happen, this will lead to short circuit of source. So here we can see the gate pulses, the gate current. So first the waveform will look like this. Then again this is for T1 and T2, and this is for T3 and T4. So T3, T4 look like this, and next this is output voltage waveforms. So it look like this, then it comes like this. So this is the output waveform. So here T1, T2 conducts, then again T3, T4 conducts, T1, T2, T3, T4. So this is the output voltage waveform of a full bridge inverter. So based on mobility of inverter, it is divided into static inverter and dynamic inverter. So static inverter has no moving parts and are used in wide range of application, from a small switching power supply in computers to large high voltage direct current application that are transport bulk power. So dynamic inverter. So in a dynamic inverter system, the charging system operates normally with the inverter off. A regulator inside the inverter controls the changing voltage. When the inverter is turned on, the alternator is disconnected from the vehicle battery and is tied into a transformer that uses electronic controls to change the DC alternator input into AC inverter output. So this is about the dynamic inverter. Based on the nature voltage source inverter. So in voltage source inverter, input voltage is maintained constant and the amplitude of the output voltage does not depend on the load. However, the waveform of load current as well as the magnitude depend upon the nature of the load impedance. Current source inverter. So in current source inverters, input current is constant but adjustable. The amplitude of the output current from current source inverter is independent. So as we see here in the current source inverter, this is the DC output voltage. This is phase and this is neutral. So here we can see this is the motor and this is high voltage IGBT. So this is one IGBT and this is another IGBT. So total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 IGBTs. So this is a current source inverter circuit. So characteristics of a good inverter. So its output voltage waveform should be sinusoidal. Its gain should be high. Its output voltage and frequency should be controllable in a desired voltage. The power required by its controlling circuit should be minimum. So characteristics of a good inverter will be voltage waveform should be sinusoidal. And next the gain should be high. and next its output voltage and frequency should be controllable in the desired voltage, and next the power required by its controlling circuit should be minimum. So conclusion, so inverter is a simple but versatile circuit. Next, it is extensively used as buffer in the output stage. So inverter is a simple but versatile circuit. It is essentially used as buffer in the output stage to reduce the loading effect of the previous stage. Next, used as a basic block in many analog circuits like oscillators, amplifiers. So summary, so inverter definition is studied, and next history of inverter is discussed. Next, applications of inverters discussed, kinds of inverters are discussed, use of inverters is discussed, classification of inverters is discussed, single phase full wave inverter and operation is studied, static inverter definition and use is studied. Next, voltage source and current source inverters are discussed, dynamic inverter definition and use is discussed. Next, characteristics of good inverters are discussed, and next conclusion is discussed. So these are the summary of my today's topic, inverters. Thank you.